Okay, cool. Hi, everyone. If you can't hear me, please shout. But then I guess you can't hear me, so you don't know what to do. Well, I'm just gonna keep talking for about 20 seconds because that's how long the lag will be. And if you can't hear me in 20 seconds, please let me know. Okay, so someone's telling me it's working on Twitch. I hope this means the sound is working on Twitch. If not, I'm just gonna keep talking. Anyways, welcome everyone. Thanks for joining us in our first online meetup. And for those who are joining us from Software Circus, hello, we're ServerlessDays Amsterdam. And we are so happy to have you. Oh, great. People are telling me it's great sound-wise. Thank you so much, Mark. So, ServerlessDays Amsterdam. Yes, we are starting with the slides, which apparently we're not starting with the slides. What is happening? Okay, quick check. Right, so this is the Meetup edition. And not only is this the Meetup edition, it's the online Meetup edition. For obvious reasons, we moved this and everything else, and everyone moved everything else online. So super happy to have you here with us. So just a quick thing, as I said before, Serverless Days, we are here today with our good friends from Software Circus. And so if you're here from Software Circus, hello, please join our community on Meetup or on Discord or on Twitter or on YouTube, wherever. Just look for Serverless Days Amsterdam and just join that. And I'm just going to tell you a little bit about the history of Serverless Days. So this is a global group of events, which used to be called JeffConf. And I think it was it Anne Stanley or was it Paul? I think it was Paul who said that serverless is just a name. It doesn't really matter. We could also call it Jeff. And thus JeffConf was born about, I think, 3 or 4 years ago in London, because there was another serverless conference that didn't make it. And people were so annoyed that they were like, oh, let's just do our own serverless conference. And that was JeffConf. So today, there are Serverless Days events all over the world, literally. So everywhere where you can see a mascot, there's a Serverless Days conference or maybe also a meetup. And if you can't find yourself or the place where you're living on this map, feel free to go to ServerlessDays.io, reach out to one of us, and we will help you set up your own serverless days. So it doesn't mean that if you say, oh, I don't have a serverless days here in Kazakhstan, please create one. No, you have to do it yourself. That's the whole point of a community event. So anyways, we're here in Amsterdam or wherever you are right now. And this was Serverless Days, the conference last year. Yeah, it was great. We had great weather and we were still allowed to go outside. So that was nice. And it was a huge success, I think, because I organized it with the help, of course, of lovely people who are also joining us today. And yeah, this was, I think, a lovely event. One of these people, the person to the left, is also then has joined us on the organizing team because it went so well. So yeah, we are planning to do this again this year, actually. So we're a bit behind on schedule announcement. That's kind of my fault because it's been quite busy the last couple of weeks. But we have picked all the speakers. We will announce the schedule soon. Stay tuned. And on May 8th, we will have our conference as planned, just that it's going to be online. So yeah, if you want to join us for the conference, the Serverless Days conference, you can go to serverlessdays.nl or serverlessdays.amsterdam or amsterdam.serverlessdays.io, or you just scan the QR code. I will put this slide up later also in case you are asleep right now or had to get a drink. And yeah, you can get a free ticket. Cool. So for today, this is our agenda. So I'm doing the welcome right now. And for some reason, I said that 6:20. Is that right, Mark? Are we going to start in like a minute with the next talk?
I hope not. No.
Okay. Well, maybe I copy-pasted it wrong from the Meetup site. That is very, very possible. So contrary to what it says on here, we're going to start at 6:30 with the first talk. And then we're going to have a Q&A session after the talk. You can send in all your questions through the YouTube chat, through the Twitch chat. I just learned that we are also on Periscope apparently, and I have never used Periscope because I'm old. So if there's a chat, put it on there too. I think we're going to get that as well. And then we're going to have a short break for you all to, get a drink, go to the bathroom, walk around in your apartment, and hope it's not too big because you might get lost. And 10 minutes later, we're going to start with the next talk, which is going to be Kay Schollard from former Microsoft. Again, a Q&A session, and afterwards we are going to have a networking and chat on Discord where you can talk to the speakers. They're also on Discord right now, so you can talk to them already. They might not be answering you though. Also, another thing is that we pre-recorded. We have these talks pre-recorded, so we're gonna make them available as quickly as we can after. Should be pretty soon. Jojo's saying that he's already here, so you're free to harass him right now, immediately. Okay, cool. So just quickly going over our rules and the information. So we are recording this, and it's also being live streamed to YouTube and to Twitch, which you hopefully know because you're watching this. But in case you didn't, and for some reason you still see this, you can go to YouTube or to Twitch, or you can go from YouTube to Twitch if you like that more. You can also, as I said, join Discord to talk to us, to not harass Jojo because he doesn't like that apparently, via this link. And you can also you cannot, you have to follow our code of conduct on all those platforms. And it's the same code of conduct we have for all Serverless Days events. So hopefully it shouldn't be new to you. Short version is don't be an ass. If for the long version, go to that link. All right. This is our mascot, and this is the slide that reminds me that Mark and I are supposed to have a quick conversation now until our first talk is starting. So, Mark, how are you doing?
I'm quite excited actually for this whole event, but I think we're doing pretty well so far. I really liked your intro, especially that you mentioned that the offline conference was so successful because you organized it. I think that was the highlight of of the intro.
Well, everyone who was there can totally attest to. I'm not going to say it was me. I'm just going to say it was a very, very cool conference.
It was. Yeah.
It was amazingly, there were no problems. Even the sign up went without any problems, which, to be honest, that's just not something that happens. And it was a great day. It was I think we had it in April, right? Like about the same time.
Late March. Yeah, exactly. Yeah.
Oh yeah, end of March. It was end of March, I think. Mm-hmm.
Yeah.
And the weather was amazing. It was like sunshine, and we could sit outside after the conference in Amsterdam.
Lovely. Yeah,
that was great.
Yeah, it was great. Yeah, I mean,
you sure missed something, people.
Yeah. Let's do an offline one again next year because it was really great. But this online version we're preparing will also be very nice, definitely.
Yeah, it will be amazing. We are guaranteeing that right now already. Yeah, I mean, we just talked about this briefly before the meetup, but after this whole thing is over, we do want to take this offline again, maybe do alternating online-offline events, because it's just nice to have that local community feel. I think that's one of the things why Serverless Days is working so well all over the world is because it is Serverless Days, but everywhere it has this own local touch. It's always organized by local people. And it's not like one big vendor just like splurges on like, let's just do this everywhere. But it's just like it's a labor of love, and I feel like this is kind of why people like it so much. Again, not tooting my own horn or anything, but that's
I think
kind
you're
of
right.
at the core of
I'm
it.
certainly hoping you're right. I think that's the case indeed. Yeah, no, definitely. Yeah, we'll do a
Yeah,
nice mix. I think that will work out quite nicely. Yeah, agreed.
yeah, for sure. So, yeah, okay, I see people are joining us on Discord. That is great. Hey, so the thing about Discord is, if you're not familiar with that, so not like Slack, on Discord, you are just automatically joined to all the channels automatically. So you don't join the individual channels. So you can always see everything that's happened on the same server. And yeah, we kind of like split everything up in like separate servers, separate channels in like segments. But to be honest, if you post anything anywhere, we'll see it. Just be nice. That's all we're asking. Sorry about that.
Okay, shall we start
So
with the first session?
are we already? I mean, it's still 5 minutes technically.
Oh, you're right.
If we take the difference between the wrong time that I posted on the agenda and the correct time, we could start now as well. I'm cool with that. I hope that people have joined already, so we can for sure start with the first talk. I know that they're like 30 to 40 minutes, I think. So yeah, we can start a bit earlier.
Yeah,
Are we good?
I see that we have 36 people on YouTube and 17 on Twitch. I think those are very nice numbers. So let's go for it.
That's more than we ever had for our meetups, so I'm good.
Okay, here we go. Enjoy.
Right? Cool.
So today we're gonna learn a little bit of Knative with AWS Lambda concepts. So I'm gonna show you how Knative works, and we're gonna migrate in a very simple AWS Lambda serverless application to the Knative infrastructure. So I'm Jonatas, people call me Jojo. I'm a cloud native engineer at Container Solutions. And if you wanna find me on Twitter, just use that handler, Jonatas Baldwin. Also, if you ever see an alpaca, just pet the alpaca, feed the alpaca, just hug an alpaca. They're amazing animals. So yeah, that's what I'm gonna do today in this talk. I'm gonna show you what is Knative, how it works, and to show practically how we can use it, we're gonna migrate an AWS serverless application composing with an API gateway, Lambda, and an SQS queue message. What is Knative? It's an open source serverless platform on top of Kubernetes. So Knative brings all the open source characteristics of scale to zero, or just running the code that you need to use, and just like packaging a little bit of code, a function, shipping somewhere, and not worrying about infrastructure. It creates this experience on top of Kubernetes, which is already a well-defined orchestrated tool in the market to run Docker containers or other kinds of containers. So that's what Knative is. You can see it as building blocks or as a platform. A platform because you can just install Knative in a Kubernetes cluster and use it right away, or a building block because you can use the Knative natives, the constructs, the resources from Knative, and create your own serverless platform, as all these companies are actually doing. So they're using maybe a little bit of Knative, or maybe the whole thing, or maybe just a spec. But all these companies, all these big companies, they're actually using Knative in production in their own different environments today, which is pretty amazing. So you can see it is a platform that it's still like on 0.13, the version, I believe, but it's stable enough and it's awesome enough to run below all these great products. So I think it can be one of the features you're going to see a lot, the futures you're going to see a lot in the serverless space. It's going to be Knative. So note about self-hosted, it is an open source platform, so you can clone it, you can fork it, you can customize it, you can do whatever you want with the code, kinda. But once you self-host yourself, if you already have your Kubernetes infrastructure and install Knative on it, you don't have the no server management value from serverless, right? So we all like AWS and Azure functions and Google Cloud functions because I write my codes, I put it there, and I don't care anymore. But with Knative, it's a little bit different because you need to manage, you need to install it somewhere, and you're usually going to manage the Kubernetes cluster as well, at least maintain it. So you can see that Knative has two main target users, the platform team, who's going to get up and running and maintenance and everything, and the development team, who's going to be actually the end users, who's going to develop the functions, develop the code, and put it to run. Today I'm going to focus way more on the development team with a little bit in between to show you how it works under the hood, but our main focus is going to be on using Knative by itself. So the Knative core has two main concepts, two main components. One is called serving. So think about serving as a Lambda function with a very simple API gateway. So it handles HTTP workloads, so you can listen to HTTP and be exposed to the internet and talk over HTTP. The package mechanism to create a service under Knative, a service is kind of like an AWS Lambda function. It's packaged in a container, now in a Docker container. So write a code, put in a container, and give it to Knative to run. Of course, there is a runtime, there is a contract, the way that you need to run this container, but the way you use it allows you to run applications like Flask, Django, Express in Node, or very simple Golang HTTP servers. But the way you think about it, it's actually a container. It scales to 0, so if there is no traffic, not using your services, it goes down to 0. And it also has traffic splitting built in, so you can actually do some kind of canary release. You can have two different versions of your service receiving traffic at the same time, so you can do like some A/B testing, some canary release that's built on the core of the platform. And you also have the eventing part. So the event is an event-driven system. So you can think about like the AWS infrastructure, like SQS, S3, SNS, generating these events and triggering like a Lambda function, for example. That's how your mental model can be about it. So basically interacts with serving. So we're gonna have these services in our platform, and it's gonna react to these events. You can have custom event sources, which is quite nice. So where does this event come from when in Knative? So you can build your own. So the community builds some event sources to fetch events from an SQS, for example, or to listen to a GitHub webhook notification. So you can build your own event sources. And all these events should be, and they must behave into the Cloud Events standard. So Cloud Events, it's a spec that defines how a message should be composed. So when you use Google Cloud Functions or Azure or AWS Lambda, those messages, those events they receive, the context and the data, they all look different in these platforms. And the Cloud Events created a spec and some SDK, some actual implementations on how to package this message so you can have like the same feeling and the same experience across providers. And the Knative eventing uses that. So we're going to see that how it behaves a little bit later. And also Knative is built on top of many technologies, mainly these ones. If you work on a platform team, if you're managing Knative, you're probably going to need to have some knowledge about these tools, so you can understand how to debug your system and how to deploy it and how to maintain it. But for a developer, for the one that is actually using the tool, just deploying the functions, I would say some knowledge of Docker and a little bit, just like a tiny little bit of Kubernetes, it's essential. But other tools, you don't need to know them much. So as complex as it looks like, for the end user, you're just going to see very basic stuff. So yeah, let's work on some code, right? So what we're gonna do, we have two serverless applications, an API gateway in Lambda, very simple integration, and SQS in Lambda, also very simple, just reacting to some events. And we're gonna migrate that to a Knative infrastructure. So the Knative that I'm gonna use now, it's hosted on the Google Kubernetes engine. So it's running some Kubernetes somewhere. And the two modifications that I did from the vanilla installation that you can find on the Knative documentation it's that I enable the HTTP certificates. So I'm gonna have HTTPS communication, and I put my own custom domain. So I can actually expose this to the internet, and makes the playing around way more enjoyable and nicer. So yeah, before I get to the codes, I just want to talk a little bit about the serving architecture and design. So when you build your service, you can again think about a service like an AWS Lambda function, for example. You just build like one thing called a service. You give it a name, you give it a container to run, and Knative on the back is gonna create for you this other component. It's called configuration, which is gonna hold your actual like service configuration, like environment variables, for example. It's gonna create a revision, which is a snapshot of your code plus configuration. So that's actually the thing that it's running your service. And every time you change or the code or the configuration, a new revision is created. So you have all this history on how your function grew with time. And on the other side, you have a route. So Knative is going to create a network route or route to point to this revision. So it's going to expose this service, this revision somewhere. It could be on the internet, it could be inside your Kubernetes only, but that's basically how it works. So we have a service managing all these things. But again, as a developer, you're just going to need to touch the service part. Cool, let's tackle some code, shall we? Nice. So I just want to quickly show you what we have on Lambda. So we have two functions, hello, which listens to HTTP and like just one method, just a get in this path. And we have a by, which listens to an SQS event. And when it receives a message, just prints the body message on the logs. The code is here. I'm gonna upload the code. I'm gonna have access later to the repository, so you can take a look and investigate. Just to test it very quickly, I'm gonna go into Lambda here. I'm gonna do an info. So this is the hello endpoint. So I'm gonna curl it, and you can see the message, which is stay home and stay safe in these times of quarantines. And the logs, I'm gonna do ss logs -by -f by. So these are the logs from this by function, which is none now, but I'm gonna send a message there. So I'm sending a message, I'm just gonna slide this down. Sending a message to this quarantine Lambda queue, and with a sub body, and when I send it, cool, I'm gonna wait like 2 seconds so the function can trigger and do some stuff. And when I take a look at the logs, maybe again, there we go. It just printed our body. So we're gonna try to mimic, recreate this behavior and experience in Knative. Again, the code's gonna be here, and in the end you can take a look and access, and then you can compare with the Knative code we're gonna make. Cool. Let's do some serving on Knative. So let's first focus on this hello function here. Nice. So this is the serving part. So this is my code. So basically I have a very simple vanilla Golang code. This you can run in your machine. You can put in a container. You can probably run like in a PaaS infrastructure. This is very vanilla Golang. You listen to this port 880 and you have an HTTP server running there. So this is the contract that Knative expects from a service. You listen to a port, default 880, and you serve an HTTP web server. So you can do that with any language. You can do that with any framework. If you do that, it's going to be able to receive requests and respond to those requests. So this is the code, right? So I'm going to quickly build a container image. So this is the Docker file. So this is how we put that code inside a container for Knative. So this is as simple as possible. You can optimize this in different ways, but I just made like as simple as I could. So in the Golang world, you basically copy the code inside the container. You build a binary, because Golang works with binaries. And then you expose this binary for the container. So when they run, it's actually going to run this thing for you. So I'm going to use this build command. Oh, shouldn't be here. It should be in serving. Knative serving. Cool. I'm gonna build, and I've built this before, so it just takes no time. And then I need to push this somewhere. So this command here pushes my image, my container that I just built to the Docker Hub repository. So my Knative server can actually go there and fetch this container. Again, if you need to host like some private code, some private stuff, you can have your own Docker repository. Again, I also pushed this before, so nothing happens here. Cool. So let's take a look at some Knative now. We have our code, we have our Docker, our package system, and now we're going to deploy it. So we're going to use the key-in command line for the Knative, and I'm going to create a service, right? So service create. I'm going to create one called quarantine Amsterdam, and then I'm going to give it an image. It's going to be quarantina. So what I'm doing now is I'm basically just creating a service and giving the Docker container just build and push. And there we go. We have this endpoint here. So this endpoint should listen and just exposes my web server that I have in this file, right? I'm gonna curl it, but it might not work. Again, it takes some time to generate the HTTPS certificates. If I curl it with HTTP, it works quite fine. So in a bit, the HTTPS is gonna start working. I'm not gonna bother with that right now. I promise. So yeah, this is the serving part, which is quite cool. On the screen on the side here though, I can do some nice other things. So I can actually run this command here. This is a Kubernetes command called kubectl. This is how we interact with a Kubernetes cluster. And I'm gonna get all the pods which name quarantine Amsterdam. So the pods is like the minimal thing that you run inside Kubernetes. So you can think about a pod equals like a function, equals like a service. It's not quite the same thing, but you can think about it, which is gonna make like your experience a little bit easier. And of course, you can deep dive and understand all the technicalities of it. But as a user, you can just think like, well, pods kind of like a function. So you can list all the pods. So this is the pod. You can see it's terminating because it's scaling down to 0 right now. So if I trigger it again with the curl command, now with HTTPS it's working. A new pod gets up with my container, runs my code, gives me an answer, and it's gonna go down in a bit. Nice things that I can do is that I can update the service, for example, quarantine Amsterdam, and I can use a mean scale to 1 service update, for example, and I can give it a mean scale to 1. So instead of scaling to 0, it's just going to scale to 1, right? So with this, I basically eliminated the cold start, for example. This is one thing that I can do. It's this fine-grained scalability. I can control how the scalability works. As an example, another change that I can do is I can easily pass an environment variable called name equals Jojo. And again, you can see that every time that I do these updates, things are destroyed and created. And here, on this 1, 2, and 3, you can see the revisions. So you can see the versions of my function. Now the version 1 is running, the version 1 is dying, 2 is gonna die in a bit, and 3 is running. So if I curl it, now we can see that the environment variable gets here from this part of my code. Cool. So this is like eventing. You can actually see some logs as well. So there's Kibana to take a look at logs. So I can grab my revision name. So key-in revision lists. I'm gonna get the second one, and I can put it here. And I can see some logs from my infrastructure, from Kibana. This is a very standard dashboard to see logs. And also we have Grafana to see Prometheus metrics. So actually everything has a metric already on Knative. So for example, we can take a look at the HTTP requests on the quarantine Amsterdam and how many operations we had, all the revisions you can take a look. So there's like some metrics and some logs out of the box. You can take a look at any of these dashboards. It's very, very interesting information on that. can explore that later. So yeah, that's like metrics, logs, and that's basically how the eventing works. There's more things like traffic splitting, and you can limit the concurrency and then scalability a little bit more, but this is like the basics, how to get piece of code from the computer running in Knative. So write your code, put in a container, ship the container, Knative is going to do everything else for you. Cool. So besides the serving, we also have the eventing system. So the event system, I'm going to put it a little bit bigger. There we go. So the eventing system, it's like our event driven, right? So this is like getting events from external sources and putting them somewhere. In this case, this is how it works, the architecture and the design for Knative. You have like external services like Amazon or GitHub that are going to fetch or receive events from. You're going to have a source, which is basically like this controller, this piece of code and logic that fetches or receives the event. It publishes through a broker. This broker is like this magical place where all the events gets inserted into. So you have this broker, receives like events all the time, and then you have triggers, which is like the thing that goes through broker and fetch some specific events, apply some filters. So if you want an event for a specific type or from a specific source, you have like some fields that you can filter these events. And once there's an event with that filter, it sends this to a service. All these components are very, very like loose couple. You can deploy them in different orders, for example, and you can like substitute them very easily. So it's a very, very loose couple architecture as well. And also there is this kind of like not hard separation, but in my point of view, as a platform team, you're gonna work way more on like developing the sources, these controllers, or using controllers already built from the community to get these events, and managing the broker as well to receive these events. And from a development perspective, you're gonna probably write triggers to fetch these events from the broker and write services. So for the dev team, it feels like way serverless that you just go like, I just want to receive this event and trigger this function. I don't want to do anything else. So again, this dichotomy, right? You're gonna have people running, people managing, and as a developer, you shouldn't care about it. The infrastructure should still be very transparent to you. Yeah, so let's do some more coding and take a look at the eventing system. All right, I'm gonna clear it up here, cancel this comment here, and I'm gonna go into the eventing folder. Cool. So I have this consumer, which is basically the source. So the source is basically this part of our architecture, right? The source. And the broker is it's already enabled in my environment. And I'm not going to show you how it works. You can take a look at the code later. But basically, it's a Golang application that goes into the SQS and queue and fetch some message. So like every 5 seconds goes, gets a message. It was built by Trigger Mesh, so I'm just using their own consumer. Just explaining how it works, and here's the codes. It's gonna be on GitHub, so you can take a look later about that. So don't worry about the source for now. Let's worry about the consumer, where the nice part is. So here we have the consumer, right? So what is our consumer it's gonna do? The same that our Lambda function is doing in our serverless example. It's gonna get an event and just print it to the logs, right? Just print it to the output. Again, cloud events. This is, you can see the cloud event spec. So one thing that the source is gonna do, it's gonna go fetch this event, and it's gonna put inside the cloud events package. It's gonna create this cloud event metadata. So the consumer understands how to read this data, and the trigger understands which field it can filter this data. So everything happens in the cloud events. So imagine that the JSON that SQS sends a Lambda, it's going to be transformed middle way, and it's going to be sent to our services in Knative, and in the end, it's just going to publish to the output, and we can see it in the logs. So this is what our code is going to do. Again, the way we're gonna package Docker file, very, very simple. Think about like you zipping our the AWS Lambda function, we're putting our function in a container. And this is the consumer. So this is another way to interact with Knative, use YAML files. So everything you do in Knative, those service, those routes, those revisions, they're YAML, because Kubernetes, like the main interface to Kubernetes, it's YAML. So if you wanna put your code and your configuration in your repository, you can use this and then have pipelines to deploy it. Makes your life way easier. I already built the Docker as well and pushed, so we don't need to work on that. And the main difference is this tag here. So this basically says to Knative to not expose this function, service to the internet, but actually just internally on the cluster. So since my broken everything's on the cluster, I actually don't need to have this exposed to the internet, right? Yeah, so and I'm gonna deploy this very quickly. I'm gonna go to eventing and into consumer. So kubectl, this is the Kubernetes CLI. Apply -f, and I'm gonna have the consumer. Cool, so my consumer is being created right now. Again, it's a container running Knative, right? It scales to 0, all those things we saw of service. Instead of listening to a port 880 on any web framework, it listens to Cloud Events methods using the Cloud Events SDK. And there's a trigger. So this is like our glue between all of those little components. So the trigger basically listens to a broker, default, we already have one. It make a filter in some attributes. So at this time, I want to have a type that it's an SQS message. So this is already defined by the source that's going to go and fetch this event. I already know this beforehand, so that's how I did it. And the subscriber. So once it's triggered with this message, it's going to send this message to a consumer. So you can see how loosely coupled this all is. And to deploy a trigger, the same. You can use the Kubernetes CLI. K is my shortcut for kubectl. So trigger. Cool, so I have a trigger. Nice, so that we can take a look now into our service. So what is the name of the service? We'd call it consumer SQS. Cool, so there's no resource because it's scaled down to 0, I hope. Actually, it's the serving service. I'm gonna get all the pods, I don't know the tag for sure. It's here. It's another tag for like an eventing tag, but it's here, the quarantine one. Cool, so it's waiting for this message, right? So I'm gonna go to SQS now. And you can see here the broker and the source SQS are always all running, but this is the piece we just deployed. So I'm gonna send a message to the quarantine Knative, as you can see down on the left. So I'm gonna send a message to this specific queue that's Knative is gonna receive a message from this queue, right? Cool, send a message, and then you can hear it's triggered. Here, the consumer is triggered. I was talking about the quarantine this before. This is our service. Don't worry about it, I was mistaken. This is the consumer. This is the one that actually got our data, and I'm gonna use this tiny little tool called Stern to watch the logs. So Stern just watch logs from Kubernetes pods, and you can see here, that's my data. That's the events received from, actually, can I see it better? There we go. This can see it better. So this is the events received from my source. So my source went to the SQS, fetch it, sent to the broker. The trigger got triggered my message, the service saw the message. And this is the cloud event spec, as you can see. You have the spec version, and you have where it came from, and you have the data, which is actually the JSON from AWS. So it all come together and was delivered to my function. So that's about how eventing works. Isn't it nice? Oh man, I love this architecture so much. So this is what you just saw, and it's so easy and so quick to build all these things. Yeah, but I love it. I love this architecture. Cool. So we just did it. So let's close with a note on the improvements. Things that I think Knative could improve on. I think the developer experience is one of the things. It's still a little bit raw. You have the CLI, which is awesome. But I think there's going to be like some more tooling, and there's going to be more like dashboards and just ways of interacting with the platform. If you want a very good experience on how to interact with Knative, just use Google Cloud Run. It uses like Knative spec on the background. We don't know if it runs in Kubernetes or whatever it runs, but it's a nice dashboard. It's a nice CLI. It makes the experience way nicer, and you're actually not exposed to any kind of Kubernetes, which is amazing. So I want to see more on this developer experience in the future. Eventing is a little bit rough on the edges, I would say, because these consumers are built from the community, and some things are getting deprecated midway, and these consumers don't get updated. So I would say there's a lot of work, and it's an amazing team working on that, but I think we're going to have way more stability in the future. So I think it's getting there, and we're probably going to see more high-level stuff on top of this. We have, for example, parallel and sequencing, so you can actually do like kind of workflow architecture for functions, just make one service trigger another, for example. So these are the things that the eventing team is working at. It's coming together, which is quite exciting. Education and content. We have a bunch of blog posts and courses and everything about the big players, and we don't have too much about Knative so far. So I would like to see more texts, more videos, more Stack Overflow questions, more things happening in this world. So when someone has a problem, it's easier to find. Today, if you have a problem, you can go to Slack. People there are amazing to talk to you, and you can also raise issues on GitHub. It's pretty active project, so you can get an answer very fast. But again, I would like to see some more education and content around. And again, server management. This is a part nothing to do. Someone's gonna need to manage this for you if you wanna host yourself, or you're gonna need to host yourself and use yourself, which is a little bit overkill. So there's no way around. One of the principles of the serverless is no server management, and from a developer perspective, you shouldn't see it any kind of infrastructure, but someone in your team or someone in your company is going to need to manage and maintain it. So it's a thing that we can actually don't do anything for now. And this is the awesome list, things that I think it's amazing compared to other providers. So backed by big players. So it is a Google project, and people from IBM, Red Hat, Trigger Mesh, Pivotal, VMware, they're all working on this platform. So it's actually a bunch of very, very nice and awesome people working on it. So you can see the market has a lot of interest in this tool. It runs in Kubernetes, and as much as Kubernetes is complex and it can be hard and it can be a pain sometimes, it is a default orchestrator tool in the market. It's everywhere. If you have Kubernetes knowledge today, you can get a job like this. So it is an amazing tool, although it is a little bit too much sometimes. It's awesome that it uses all this already battle-tested infrastructure that Kubernetes gives one to build platforms on top. Observability, this is awesome. You have a lot of observability in your containers, so you know which operational system is running. The language runtime is not a black box anymore. You can actually tear apart and see how it's running. You have a lot of observability tools for Kubernetes clusters, so you can actually understand how Knative works under the hood very easily, just by looking around. So this is a well-defined realm in Kubernetes, and it's just kind of transported through Knative. You can kind of avoid locking in quotes, because since you're running on container, it's very easy to move around. You run on Kubernetes, which runs in different cloud providers, but it's still if you go with one cloud provider and starts listening to their own events, for example, you might need to do some change when you wanna if you wanna listen to events for another cloud provider, for example. But I would say moving a Knative infrastructure, it's possible, while moving an AWS Lambda infrastructure is actually not. fine-grained scalability. So as you saw, you can set like mean scale, and you can eliminate cold starts. You can set CPU, the usage of CPU and memory and the concurrency, how many requests your service can receive. Have so much control over how it scales, to how much scales, to how low it goes. So I love this control and these tweaks that I can do to the platform. And also cloud events. It's an amazing spec, and I think it should be used everywhere in all the providers, and I think it is the future, and they've been using on eventing like since the beginning. So having this very nice, very robust spec to deal with messages, it's just amazing. Cool. More stuff that I didn't discuss, and if you like to go and take a look, you can select traffic splitting, and there's tracing as well. There's sequence and parallel that I just talked about on the eventing, which is like high-level components. Just go and explore. There's like way more, a lot of information out there about this on the documentation that you can go and explore. And if you need more resources, Knative Dev, the docs, mainly where you're gonna learn everything about Knative that you need to know. And GitHub, where the source code is hosted. There's Slack, pretty active, awesome people there. Twitter, Twitter. And the code from this presentation is gonna be on this GitHub repository down there. So you can go, I'm just gonna write like a nice little readme, and then you can understand what happened there. But yeah, if you wanna, and also like there's a bunch of YouTube videos, just go on YouTube, type Knative, like a lot of stuff there. So it's very good to understand and to use the platform. Well, thank you very much for your time. If you want to find me, if you want to discuss anything with me, that's my handler. You can easily find me on Twitter, send me a message. I would love to talk about Knative. I think it's an amazing tool, and I think it's gonna change the way we see serverless in the future, especially for like self-hosted platforms and also for the big providers. Thank you very much. Cheers.
Now. And we're back.
So awesome. Hey, that was great. I hope everyone can hear me again. If not, I guess like shout. So thanks for that. And while you were speaking, actually, I realized, and I'm so sorry about that, I forgot to introduce you. So everyone who was watching your talk was now wondering, like, who is this handsome person that's speaking? So, hey, Jojo, why don't you just introduce yourself really quickly?
Okay, yeah, thank you for the handsome person. I really appreciate it. So I'm Jojo. My name is actually Jonathan, so people call me Jojo. It's a little bit easier. I'm from Brazil. I'm currently living in Berlin, working for a company called Container Solutions.
So, Jojo, I think you are muted because I cannot hear you.
What's up? Can you hear me?
No, I don't think. Well, I can't hear you.
Can other people hear me?
Yes, I think it's fine.
Okay.
Yeah, you can continue.
So while we're waiting for Jojo to figure out his tech, I'm gonna check on comments and questions and all of that. Oh, you can hear Jojo. Okay, great. Then
Yes.
I don't know what's happening on my end, but I will try and fix that on my end. And Jojo will continue to introduce himself.
Okay, so I was talking about working, right? So yeah, I work for a company called Container Solutions here in Berlin, and yeah, I'm enjoy serverless a lot. I've done some stuff on AWS, on Azure, on Google, and I really enjoy the open source part of it. So I contributed to OpenFAS a little bit last year, which was very nice. It's an amazing community, and I'm taking a look now into Knative, which is also quite cool. So I really think there's a lot to explore in the open source world of serverless as well. So yeah, that's me. On a more personal note, I do enjoy coffee quite a bunch, like very nerdy on coffee lately.
trying different brew methods and stuff like that. Training for a marathon, that's a thing, I think. Not going outside too much for a run on these days, but try my best to continue training somehow. And as always, stay safe, stay home. Don't go outside. It's dark out there.
Cool. Thank you. And I can hear you now. Awesome.
Nice.
So, so this is the thing. Obviously, Kubernetes, the container people and the serverless people. You know what I mean, right?
We can all be friends.
Well, that's the question. So Mikhail, I hope you forgive me for telling this to people, but it's just so funny because while we were, looking through the proposals for the conference, there were quite a lot of people, proposing talks like Knative, and like serverless and containers, whatever. And so there's one person in our organization team who has very strong opinions on Kubernetes, and I asked him if he would join this call so we could have a short discussion, and he just flat out refused, and he was like, let me just see if I get this correctly. What he said: I try not to comment on tech with K in its name. And then he said, even though I deployed an EKS cluster today, but I won't comment on that. But, I mean, you just can't. And I think that's kind of the question that I want to ask you is can you even avoid Kubernetes at this stage of technology where we are? It's just everywhere.
Yeah, it is just everywhere. And as Hightower once said, it's a platform to build platforms. So it's not the end game. It's going to become even bigger, I would say, before something else comes and take its place. I think it's gonna grow a lot. And when you talk about containers and serverless, I think serverless in the end is running containers somewhere that you just don't know. And the experience that you have with Knative, it's almost that you don't know. So you're still writing your container, you're still dealing with Docker, you're still writing some YAML around here and there. But I think as the platform evolves and as the developer experience in the platform gets better, you're going to see less and less containers. So I think it's going to get to a point that you can pick, you can choose. Do I want to actually pack my function as a container or just as a file and put somewhere, and the Kubernetes cluster is going to take care of me? And as I said before in the talk also, I really think the whole managed situation, it's quite tricky because people say I don't want to manage my servers. But then, someone in AWS is managing the servers for real, right? There is a platform team somewhere managing. As a developer, you're not going to need to manage, or you shouldn't need to. So I think Knative is going to be good for an organization that you have a platform team, and that you have someone else, some team, dealing with all the infrastructure. And as a developer, you're going to see very, very little. You're going to see this thin layer, which for you is going to feel like serverless. You write some code, package it in a container, put somewhere, and you forget about it. So, yeah, I think we can all be friends. I think.
So you're saying there's a use case for everything, or there's a tool for every use case more.
Yeah, and they yeah, I think so. And you can have tools for different use cases and tools for the same use cases. And I think the same experience of serverless, the same values you can deliver in different ways. And I think what Knative tries to do is deliver the same experience using already defined technology in the market, as well as other open source serverless platforms. So yeah, I think you can have the same vibe. You can have the same, just throw some code somewhere, don't worry about it, depending on your company.
The same experience.
Yeah.
Yeah. Yeah, cool. Is there any use case where you would say this, I wouldn't recommend using Knative here?
Look, I think any case that you would say you wouldn't recommend Kubernetes, real-time software development, or when you have a system that is not that dynamic and you need very real-time results, and you have massive computer as well, massive processing, that Kubernetes usually is not recommended, because even though that you use Knative, you don't need to have the cold starts, for example, you can disable that. So I think everything that you can run in a Kubernetes, you can run in Knative, practically. But I think if you need to do some hardcore software development, then I wouldn't recommend it.
All right, that's a good point. So I'm still looking for if there are any questions. So Peter, hey Peter, saying open source serverless. Thanks again, Jonatas, without an H. That's the real
Without an
name.
H, yeah. Jojo is easier.
Yeah, you couldn't have known that because I didn't really introduce him. So I take that on it's my fault. Any question, anything that you would like to say, like what's really important for you for people to take away from your talk?
What I really like is that we have alternatives out there. And what I like about Knative, it's becoming a platform to build other serverless platforms, right? So you have now OpenShift Serverless, which comes from Red Hat, and it has some Knative below it. You have Google Cloud Run, which is built on top of the same Knative spec. You don't know what's running below it. It's the same spec, it's the same experience, but it's on Google. So this tool is coming, and I think it's going to change a little bit the way we do software development. And I think it might become as standard as Kubernetes is today. So I think it's a nice thing to watch out. And in the end, for the end developer, it just simplifies how you use Kubernetes. Because sometimes we, as platform team, deliver Kubernetes and hey, this is how you use it. You write all this YAML, you write some Helm packages, all this Kubernetes talk and stuff. But Knative make that very simple as well. So you might add this other layer of abstraction and give that to your developers, and they might feel better and might like use your cluster and your stuff better, I would say. But yeah, like open source serverless is wild. There's a lot of things, there's a lot of projects, there's a big and amazing community out there. So just go explore. There's like OpenFast, and there's Kubeless, and there's Fission, and there's FN. Oh man, there's Kima. Someone talked about Kima. There is Keda. There is case serving. Like there's so many names that I can just talk names here. And they're like under active development. There's very nice projects. I think it's nice. It's a different perspective on how we see serverless today.
Awesome answer. Thank you so much, Jojo. Jojo's going to be on Discord for more comments. Yes, thank you. For more comments and questions, if anything, it hits you now, like, that question, you can ask on Discord. And we're going to take about 10-minute break for you to replenish your drinks and go to the bathroom and have dinner or whatever. So see you again in 10 minutes.
Cheers.
Hey everyone. So I hope you all have done whatever needs doing. So we can start with our next speaker, who I wanted to introduce, but then he told me not to. But I mean, he's going to introduce himself anyway, because he's just much better at that. Before we do that, Mark, though,
Yeah.
do you have some wisdom you want to share?
Oh, wow, man. I did not prepare for this. Actually, no. I hope that people are just had a nice break and they had some food and drinks, and will stick around for the next session, which I'm very much looking forward to. And I really hope that there will be some nice interaction again on all the channels. So I'm looking forward to that.
Yeah, nice. We really loved seeing you all be very active on Discord. So more of that, please.
Yeah, exactly.
So yeah. So our next speaker will be Kees Schollaert, and I'm trying really hard.
Oh,
So please,
very good.
yeah,
Very good.
yeah, he's going to tell us about the newest in Durable Functions 2.0. So here we go.
Yep.
Hey Serverless Amsterdam, good evening. I'm excited to be here tonight to deliver to you my session on Azure Durable Entities. And tonight during the session I will be around in the Discord channel to answer your questions immediately. Well, without further ado, let's get the session started. Welcome to the session on Azure Durable Entities. In the next 40 minutes, I'll try to give you a basic understanding of what Azure Durable Entities is, why I am excited about it, and how you can apply it into the real world. My name is Kees Schollaert and I work as a technical evangelist at Microsoft. And on a daily basis, I get to work with software vendors that want to build their product on Azure. Now, in the last 2 years, more and more I got the question on how they could use serverless technologies best. Serverless technologies such as Azure Functions. So this is really what got me into this domain of serverless technologies, and specifically Azure Functions and Azure Durable Functions. So that's what I want to share in this session. And the story starts actually last summer, where one of my customers had a specific question on how they could use Azure Functions to solve a specific problem they have. The problem they had was that they had to detect if a device in their platform was offline. Now this might seem trivial, but in reality this is a little bit more challenging, and I will go into this example later on in the talk. But the timing of the question was very good, because more or less at the same day Microsoft announced the new 2.0 release of Azure Durable Functions, which was something I was of course very interested in, and for some reason this new 2.0 release got a feature that perfectly solved this customer's challenge. So I worked with this customer for 2 days on a proof of concept, and it turned out it was just match made in heaven. Because both they and I were very excited about how this kind of came together, we wrote a blog post about it. You can still read this blog post on my blog, which goes really into the details of what we did. And the fun thing is, this blog post was also read by one of the Azure Functions programming managers. And a few months later, in September, when they were planning on releasing the 2.0 release, they thought about what demo they could use to really highlight and showcase what Azure Functions Durable Entities could do. And they thought about my blog post and reached out to me, and so we worked to update this demo and this proof of concept. And then they used it in the actual announcement of Azure Functions 2.0. And yeah, I can explain what happened, but I can also show it. So let's just watch a few moments of this recording where they are explaining what Azure Durable Entities is, and then they show the demo.
Yeah. So I heard there's some stuff happening in Durable Functions world, but you tell us about
Durable
it.
2.0 has been in preview for a few months, and today I think we announced the GA of Durable 2.0. I think right when you said that, fireworks just shot off behind you.
Yeah, I think so.
As soon as you
we
said
had
the
to
words
duck.
durable went GA.
Yeah. Yeah, so there's a bunch of new features, but the main one is durable entities. So it's a new way of actually programming stateful functions. So if you're used to like things like an actor model. And then here you can see on our screen here that I have a bunch of simulated devices.
Yes, let me quickly pause it here because I want to share. This is my demo. This is the thing that I built and that you can actually run yourself as well. And the idea of this demo is that at some point you're going to shut down all the simulated devices, and then this dashboard, of course, should turn to red because then it had detected that the devices were offline. So by the end of this part of the Ignite session, I was of course very nervous to see if the devices were actually turning off. So let's see if the demo succeeded, if the demo gods were with me.
Take some devices offline, and then we can keep talking about that while that's happening.
That's true. There were no storage SDKs in there to manage things like the last received time. That's just being managed for you automatically by the durable entity framework.
Yeah, and as you can see, I've turned off half the devices.
Going red now. It is very festive, though.
Yeah, it is. Yeah.
That's awesome.
So this has been great, like fantastic. Durable Functions 2.0, GA, use entities.
Yeah, you heard it. He said it. Use entities. So actually, that is what this session will be about. What does it mean to use entities? The rest of the session breaks up into 4 chapters. First, we're going to look into Azure Durable Functions, because really Durable Functions is a set of specialized normal Azure functions. And then at the end of this session, we're going to look into one of these specializations, which is new, and that is durable entities. But first, let's take a look at all the other capabilities Durable Functions has. Then we're going to quickly look into something called the actor model, because Durable Entities is an implementation of this actor model. Then, of course, we're going to look into what Durable Entities is. We're going to look into some code. And the last part of this session, I will show you some examples from the real world. Now, as I said, Azure Durable Functions is a set of specialized normal Azure functions. Now, for starters, what is a normal Azure function? A normal Azure function is a cloud service that allows you to easily build event-driven applications. You can build this application in any language, and Azure Functions makes it very easy to react on events, and then I call it triggers, and to work with data, both as something to work with as an input, and you can also easily produce data with outputs. Now, these functions run in managed infrastructure, so that makes it very easy for the developer, and it makes it also very scalable to your needs, and you only pay for what you use. Okay, so we have normal Azure functions and we have durable functions. Why? Well, if you're going to build an application with Azure functions, you will quickly discover that it is almost never as simple as a single Azure function. In a distributed world where you're going to build complex workflows, you will quickly run into challenges. For example, what if you want function A to call function B and function B to call function C, where function A then needs the result of function C for whatever reason? Or if you want to fan out, to parallelize your work and to be more optimized for performance, for example. Well, all these challenges, if you're going to fix it yourself, takes a lot of plumbing. Now, durable functions is there because we identified all these typical challenges people run into. So we built a framework, and that is called Azure Durable Functions. So it's a set of SDKs that allows developers to build more complex distributed workflows based on Azure Functions. Now let's look into the durable framework and see what specialized Azure function types it adds. And then, of course, durable entities is one of them, but we're going to look into that in more detail later on. So let's look into the 4 function types we have. And for that, we need to start with the simplest version, which is called the external function. And an external function is just the normal Azure functions. So if you're going to start with Azure functions, you probably end up building a hello world with a function 1 external based function. It's just a trigger, some logic, and potentially an output. But like I said, you're probably going to need at some point a little bit more sophistication, and for that you're going to end up with Azure Durable Framework. And with the Azure Durable Framework, there come 2 additional function types. These function types are called the orchestrator and activities. Now, orchestrators are there to facilitate the process. So they basically make sure that the workflow takes place, and they do that by triggering activities. So that's the third type of Azure functions. So, and the activities can do the hard work. They can do computations, they can go to a database or whatever I/O you need, but they always report back to the orchestrator, who can then take decisions on what to do next. Now, to make it a little bit more complex, a orchestrator itself can never be triggered by anything. So for that, we need a normal Azure function, and then it's called a client. So in that scenario, if you're going to use Durable Framework, the most simplest version is you need a client. For example, that can be triggered by an HTTP request or a message in a queue. That client is going to initiate the Durable Framework and start an orchestrator. The orchestrator then is going to make sure that the workflow starts and is going to execute or trigger activity-based functions. So that's kind of the how they relate to each other. And a visualization in this image. So here you can see the orchestrator is not doing any hard work itself, but it makes sure it's responsible for the activities, and that activities do the hard work. And that's kind of how they relate to each other. Now let's look into a demo, because this is all concepts, but we want to see code. So I'm going to show you a very simple standard durable function example. So here we have the demo project. Let me quickly make 2 remarks before we go to look into the code. First, this code is available on GitHub. As you can see, I'm currently in branch step 1, and later on we will have step 2 and 3. But you can go back to this code and try it yourself. Second comment is that this is currently being written in C#, but Azure Durable Functions is also available in JavaScript, Python, and PowerShell. And if you want to just stick to the normal external based functions, then you have even more languages available. That being said, this demo is a very simple setup of durable functions. It has a client, it has an orchestrator, and it has 2 activities. In this case, the client is being triggered using HTTP. As you can see, it's there to book a room, but the HTTP triggered client function is not going to book the room itself. Instead, it's going to initiate an orchestrator, and that orchestrator will be started in the background using the Durable Framework. And in the meantime, the HTTP response is being provided to the caller, including a reference to this orchestrator. So in the background, Azure Durable Functions is going to start up this book room orchestrator. And this book room orchestrator can take some input. And as you can see here, it's not going to do all kind of lookups itself, but instead it's going to call an activity. In this case, the is room booked activity, to see if this room is still available or not. So the output of that activity is then being used in this workflow. So the orchestrator in this case can really make decisions based in the workflow. And if the room is still available, it's going to book the room. Otherwise, it's going to throw an exception. And well, as soon as it has the booking confirmation, so basically this function is successful, then it's going to inform all the attendees in parallel. And when that has been done, this orchestrator is done. Well, it's of course very simple and naive, but just to show the concepts. And here we have the 2 implementation of the activities. So they are allowed to go to a service or to do through database or something like that to do hard work. And yeah, so this demo showed you how simple it is to make use of the framework features of durable functions, to create an orchestrator, and to implement your business logic in activities. So now we have seen the orchestrator and we have seen the activities, but what can you really do with them? Well, Microsoft identified 5 well-known problems or things you can do with durable functions. And I want to quickly go through them, starting with the first, called chaining. And chaining means function A needs to call function B, and function B then needs to call function C. And maybe function C has a result that function A needs. That's something you can do with chaining. And the second pattern is called fan out and fan in, and that you use when you need to do if you need to parallelize your work. So the orchestrator then is going to set up a list of work that needs to be done. Then it's going to trigger that, and all the activities are going to do that in parallel. And then at some point in time, it's going to fan in back so that the orchestrator can aggregate all the results of all the activities. And that is what they call fan out and fan in. The third pattern is called async APIs. And async APIs is when you, for example, have a HTTP API that might take a while to complete, but you don't want the caller to synchronously wait for that operation. Instead, you're going to give back the caller a reference to your orchestrator, and then Azure Durable Functions has an baked-in endpoint that the caller can use to see if the orchestrator has already been completed and might have a result. So that makes it much easier for developers to implement, so that you don't have to implement, for example, a status endpoint yourself. Now the fourth pattern is called monitoring, and this is this allows you to run Azure Durable Functions basically forever on a more complex schedule than you are able to do with timer-based functions. So it's really up to you what you do in that sense. And with the last pattern, you can allow for human interaction or human intervention. So let's say a workflow does a couple of things, but then it has 2 options and it needs input from either another system or a human. And with the human interaction pattern, you can implement that so that someone can give data. There can be a value or anything, so that the orchestrator knows what to do next. Now, these are the 5 patterns. They are documented by Microsoft, and actually I have a talk on it where I go very deep into every pattern and show how you can use them and what you can do with them. But that's not something we're going to do now. But we already saw a couple of them. For example, in the room booking orchestrator, we saw the sequencing. So as you can see, the result of activity 1, the is room booked activity, is being used by the second activity called room book async. Now, if you would have tried to implement it yourself using plain Azure functions, you probably need some storage to persist the state. You needed a queue to connect the 2 functions to each other, so that would have been much harder. And in this, with durable functions, it's actually quite easy. And another pattern we saw is the fan out, because in our scenario we informed all the attendees to the meeting in parallel. And of course, then we fanned in. Now, that being said, this is more or less the foundation of what you can do and what you should know about durable functions, the 101. As you can see, this brings us to the 4th Azure function type, and this is the entity function type. But before we're going to look closer to durable entities, I first want to take a look into a thing called the actor model. The actor model is invented already in the 70s when they first had to build applications that had concurrent compute going on. And they already figured out that it's actually quite challenging to build a distributed application. Because how do you make sure that all your compute is equally distributed over all the available nodes? How do you deal, you're going to run into things, locking issues. How do you make sure that your application is always available? How do you make sure that all the threads you have going on don't interfere with each other? So it might seem easy, but it's actually quite challenging, and that's why they invented the actor model. Now the actor model is actually it provides a higher level of abstraction to developers, and if developers work with it, they don't have to think about all these complex concerns around locking, thread management, etc., etc. So we have the actor model, but we also have actor frameworks, and the actor framework is actually a language specific and maybe a little bit opinionated implementation of the model that developers can actually use. And if the developers are going to use such a framework, basically everything becomes an actor. Now, what is an actor? An actor is actually a very lightweight, small entity that contains state and that you can interact with. Now, if you are used to object-oriented languages, you might think of it as an instance of an object. Now, you can never interact directly with an actor. There's always the framework in between. You can call operations on it, you can mutate the state, but it's always asynchronously. And all the things you do with an actor are always executed in order. Another principle is that every actor has a type and you can address it by an ID. So let's say you have a meeting room entity, the ID of the entity is then maybe the room number. So if I want to mutate the state of the room, for example, it's now booked, I need to know the name of the entity, its ID, and I can then put a message in the inbox of this entity saying I want to change the state to being booked. Now, important is that there is no global state, and the life cycle of the entity is being owned by the actor framework. So it might live very long, but it might also be very short-lived, depending on how much load there is going on. And for that, it's also a single-threaded thing. Now, this is a very compressed summary of what an actor is. Of course, there is much more opinion and there's also much more to read. I encourage you, if you're interested in something like this, to do that. But you can guess by now that durable entities is also an implementation of this model, allowing you to build stateful objects and applications in a serverless fashion. So what does it take to build an entity? Much like an orchestrator, if you want to interact with it, you need a client. Here we have a client implemented in C#, and this client is going to interact with our actor. To be able to do that, it needs a reference to this entity. In our case, we're going to build an entity ID using the name of the entity, room entity, and the ID, in our case, the room number. And that allows us to work with the durable framework, and we can call the method called signal entity async. And that method needs two things, at least. First, the ID of the entity we want to work with, and then the method we want to invoke. In our case, the book method. And this is what the implementation of the entity looks like. As you can see, we have only one property in the state called isBooked, and we have a method that we can invoke called book. And then in the bottom we have some magic code, and this is the required code for durable entities to be able to discover this entity and to be able to work with it. And this is what the entity and the clients look like in C#. I also have here an example of what it looks like in JavaScript. Conceptually it's the same, language-wise it's a bit different. As you can see here, we also have the entity ID and the client. We again call the method called signal entity. It also takes an entity ID and a method, and in this case we also provide it with the argument, and then the entity itself is also slightly different in terms of implementation. But conceptually it's all the same, and for the rest of this talk I'm going to stick with C#, but be aware that everything also applies in JavaScript, only slightly different language-wise. So, connecting the dots here, I explained to you what the actor model is. I showed you how Azure Durable Entities works. And as you can see by now, they are very much achieving the same things. You can address entities by its ID. The framework takes care of all the life cycle of the entity, and it invokes all the message and property changes in order, one at a time. And it's very scalable, and it can run on multiple nodes. So yeah, to me that it was already very promising. And I can conclude that an actor is more or less the same thing as an entity. So, and that also completes our list of function types. So we have the external ones, the non-magic functions, and then we have the client that can work with both an orchestrator. And now we also know that the client can also work with entities as our fourth function type. And as you can see here on the right side, here we have the entities. So clients can work with entities, but also orchestrators can work with entities. And now we're going to look into that in a bit. But first we're going to look into a demo of durable entities. So here we are back in our demo project, and we are currently in branch step 2. And in this part of the demo I'm going to show you what a client function look like towards working with an entity, and we're going to take a look at the actual entity. Now here we have the client, and this client still is there to expose an HTTP endpoint to the caller, allowing it to make a room reservation basically. So, but before we're going to work with an entity, first we need to create the entity ID. And an entity ID, you can create it by the name of the entity, the type of the entity. In our case, it's the room entity, and a arbitrary ID. Now, if we have this reference to the entity, we can then work with it using the durable entity client class that we got via this dependency injection thing. So in this case, in this scenario, I first want to see if we already have state, so that I can see if the room might already be booked, because I can ask for the state and then I can use the state to see in this case if the room is booked. And if it's booked, I can already synchronously inform the caller that this room has already been booked. If not, I'm going to do a signaling operation towards the entity, asking the durable framework to invoke the book room async method. And this is a fire and forget operation. So after this this line, in the background, durable framework is going to work with the entity. But in the meantime, this HTTP request is being completed with the message that the book room has successfully been booked. Now let's take a look into our entity. So here I have the room entity, and as you can see, this is a very straightforward class. And there's not so much magic going on. We have in this class two properties, the room number property and the isBooked property. And next to that we have a entry point for durable framework here in the bottom, which is called the handle entity operation. And this operation, this entry point is being used by durable framework to instantiate the entity when it needs to. but it's also used to be able to persist all the properties values to storage when the entity has been hibernated or killed, how you want to call it. And then we have the bookroom async method, and this is the method we just called in the client, and it's just a normal method implementation, and you can even pass arguments to it, but in this case it has not been done. Now this is just a very simple small example. I believe that you should always try to keep your entities as simple as possible, and not like a very big class with a lot of properties and business logic. But that's really up to you, because as you can see, it's just a simple class and you can do anything with it. And now I want to go back to the PowerPoint, because I want to show you the 3 things you can do with a entity. The first thing is signaling. The second thing is read state, and the third thing is calling. So let's start with signaling. What is signaling? We already saw it in a demo. Signaling basically is invoking a method on an entity without waiting for the result. So in our case, we did the bookroom async operation, and for that we needed the client, because the client was able to create a reference to the entity and then do the signal entity operation, and there was no result, and so the client function completed immediately after that invocation. And then we have read state, and read state is a bit more advanced or different, and it's not an invocation of a method on the entity, rather it's a get operation on the state. So if you're gonna use the read state method, it's going to return to you the deserialized state of the entity. And in our case, there were the room number and the isBooked properties on the room. So you cannot call a method or mutate the state. You can only get a snapshot of the state at that point in time. And that's what's called read state. And the third one is calling. And with calling, you can, much like signaling, invoke a method on the entity, but you can also wait for the result and do something with that result. So in that case, however, you cannot do that in a client function directly. So you can only use the calling on an entity via an orchestrator. As you can see in this diagram, the client has to create an orchestrator, and then within the orchestrator, we can either use the call entity async method, or we can use a proxy, and I will show you what that looks like. And then the orchestrator will get back a result from that calling operation, and that's something it can work with. So these are the 3 things. We already saw the first 2, and in the third demo I want to show you how entities and orchestrators can work together, and how you can call an entity from within an orchestrator. So here we are back in a third part of our demo. And in this part of the demo, I want to show you how entities and orchestrators can work together. As you can see, we again have a client function to start with. And the scenario for this client function is slightly different, because instead of booking a room, we're going to change the room booking from room A to room B. So this client is going to create an orchestrator, and that orchestrator will start in the background, and in the meantime, Durable Framework is going to create a status page for the caller, and then in the background the orchestrator will start up, and it's going to create a reference to the from and the to room. So again, it's going to use the name of the entity. So in this case, we're going to create 2 references to the same entity type, but of course with 2 different instances by ID. And then what happens is we're going to create what they call a critical section. And to do that, you have to use the log async method. And this basically means that it's going to create a section where all the entities IDs that are provided to this log async method, so in this case the from room entity ID and the to room entity, are being locked in this scope. So no one else can use them or mutate their state. And this is important because in our scenario we want to unbook the first room and we want to make a reservation on the second room, as you can see here. So we don't want someone in between those two lines to be able to make a booking on the from room, and that can be achieved using this critical section. And for example, in scenarios where you deal with money transfers or something like that, this can be a very important thing to be aware of. Now, something else that happens here is that we are working with a entity proxy. So before we use the call entity method and we use the signal entity method, and they are never using the actual interface of the entity. Rather, they take the name of the method to be invoked as an argument. Now, some people don't like that, me neither. And that's something that you can fix by working with an entity proxy. So instead of working with the entity client class, we create a proxy based on the interface. So my entity now has implements an interface, and that is what we're going to use to communicate with. So here we have a from room entity proxy, and now we can actually use that proxy to use typed method names. In this case, the is currently booked async method that we have on this specific entity. And that makes testing much easier, and it's also less easy to make naming mistakes. So that's what this looks like. So as you can see, the is currently booked async method is basically a calling operation. So we also could have used the call entity async, but in this case, like I said, we are using a proxy. And as we are in an orchestrator, we can wait for the result of this operation. And that is in this case a Boolean that we can use. And then at the end, the orchestrator completes after this change of booking meeting rooms has been done. So this is what it looks like if you want to work with an entity in an orchestrator, and you also learned the concept of locking and a critical section. So time for a demo. And the first demo I want to show you is the demo of device offline detection. And it's about this blog post. So it's quite an extensive blog post. As you can see, there's also quite a lot of code in it, diagrams. It goes into monitoring and all the things that you need to know if you're going to work with durable entities. For now, I want to show you the code running. I have it running on my laptop, and this code is also available on GitHub. It includes a deployment pipeline if you want to, and also an ARM template if you want to run it in Azure. You want to deploy it using infrastructure as code. So it should be quite easy to get it running anywhere. Now I have it already running on my laptop. So over here I have Visual Studio Code already attached with the debugger. And it starts with this specific Azure function. So we have a bunch of devices, and every 20 seconds that device is supposed to send a message into a queue. And if there is no message for longer than 20 seconds, we want to know, because then the device is apparently offline. And it starts here with this client function, which is triggered by this specific queue that device is sending messages to. And in the message is the device ID, just for simplification. So as you can see here, we're going to build up a reference to the specific entity, the device entity, and we're going to signal the entity that there was a message. And then it's up to the entity itself to the business logic on the offline detection. So let's take a look at the entity quickly. So here we have the entity. It's a little bit bigger than the entity I showed earlier in this session. But it's also not very complicated. Here we have the method that is invoked from the client called message received. This is the kind of the ping. And so what we do is we maintain a property in this entity called last communication datetime, where we keep track of when the device sent a message for the last time. And then we're going to do something that is actually added in the 2.2 release of the durable entities. and that is called scheduling or reminding. And what you can do within an entity, you can set a reminder to yourself that something needs to happen at some point in time. So here we're going to say signal ourself. So we build a reference to ourself, and we're going to say after this amount of time, please come back and invoke the device timeout method. And the device timeout method is defined a little bit below. And so after this 20 seconds, this entity comes back here and it's going to take a look if in between those 20 seconds, the last communication date time has been changed. And if that's not the case, we're going to report the offline state. The other way around is also true. So here we're going to say every time a message is received, we're going to report the online state. Now you might wonder, what does the report state do? And here we are using a technology called SignalR, which is a managed service in Azure that allows you to, with real-time communication with the browser. So basically we're going to report the state and we're going to send a push notification to all the browsers that are currently looking at the dashboard. Now I have a dashboard open. This dashboard is included in this project. And it's over here. So here we have the dashboard. Currently there are no devices. And to be able to get devices here, I also built a test device client where we can spawn test devices. Let me do that. So it's included in this repository. And it allows us to enter a number of devices that we want to simulate. So let's start with 10. Now we should see the devices coming up. There we have our 10 devices. And they're now online. And every time a message comes in, it's highlighted that there's a new message. So by now there should be a lot of blinking devices. And we can also update the number of devices that we want to have online. So if I now bring it back to 5, we should see 5 devices going offline because there are no new messages for this device. In 20 seconds, it takes a bit, of course. There we go. So we should have 5 devices still online and 5 offline. And this is achieved with the minimal amount of code and with durable entities and reminders. This is something very easily built. Now you might wonder, how does it scale? So I also put some time in load testing this specific project because this specific customer had to deal with up to 1 million devices at some point in time. So it needed to be scalable enough to deal with that load. And as this test project is integrated with application insights, I ran some load tests and could see when it was not able to deal with the load anymore. And with the premium function plan, I was able to scale it up to 5,000 function executions per second. And that was more than enough for this specific customer. But you should do, of course, your own test to see if it meets your needs. So this is the first demo. Let's take a look in the second demo. The second demo I want to show you is a story by Christian Legner. And Christian had to build an integration with SAP. For that, he used Azure Durable Functions, including durable entities. Now, this is an interesting story for a couple of reasons, and I want to quickly go through them, starting with the extensive blog post he wrote. And this blog post goes into all the design decisions he had to make, including things like resiliency. For example, going into the circuit breaker pattern and retry mechanisms he has built in. Now there is another reason this is an interesting one, because it's entirely built on top of Node using TypeScript. So if that's your thing, this is really something to look into, as it's a very real world example of durable functions with Node and TypeScript. Now let's go to the third demo. The third demo is built by a colleague of mine, John And John worked with a customer that ships expensive machines all over the world. To keep track of where all the machines are, they equip the machines with a GPS tracker. And just this GPS tracker emits location data to an Azure function. Now this Azure function keeps track of the order and the item and the tracker using durable entities. And he was allowed by the customer to put an anonymized version of this solution on GitHub so that we can learn from it. And this solution includes things like logging, and they are doing geofencing. So let's take a look at that solution quickly. I have the solution open here in Visual Studio Code. And the interesting thing here is that he decorated all the endpoints and the Azure functions with scenarios. So a short description of what's going on here. As you can see, most of all the Azure functions have this description. And also an interesting thing here is that he has to keep track of the relationship between these entity types. In this case, the tracker and the tracked item. And to maintain the consistency of this relationship, he uses logging. So that could also be something interesting to look into. So far my session on Azure Durable Functions and specifically Azure Durable Entities. I hope you liked it. I hope you learned something. Now if you ever run into a stateful programming challenge and you like serverless technologies, please consider Azure Durable Functions. If you have any questions, feel free to reach out to me using aka.ms WAC case. Slides and code are also available using this link. And thank you again for listening. Hope to see you soon.
Okay. Well done, Case. That was a great talk. I love the demo as well. And you did a really good editing job. Congrats.
Thank you. I spent some time there, yes. I delivered this talk a couple of times, and I think it's always great to have a good version of it on YouTube.
Nice. Yeah, really loved it. So there was a question coming in through Discord, and you did answer it there, or you started the conversation there, but I'm just going to repeat it for the people who are not on Discord. And it's quite a long question, so bear with me. So the question was from Gert. He wants to know, I want to use the durable entity as a state machine, executing some work based on triggers and stored state. The work being done is interacting with the outside world, so that is implemented as activity functions. However, these activity functions can't be triggered directly from the durable entity. You need to put an orchestrator in between. Why is this intermediated orchestrator needed? And is it maybe an indication that I am not using durable entities correctly?
So yeah, let me start with saying it's a great question, and it's actually one of the harder design decisions or things you have to think about when you're going to work with durable functions. Now, indeed, you cannot go out like from an entity directly to an activity or another function. And there's also some opinion here and there, but my opinion is that the implementation of the entity, the code you write there, is there mainly to deal with the state, to guard the state, to mutate the state. But I don't think of entities as a very strict place of a good place to implement a lot of business logic mainly. You can, of course, but then you run into issues like this. Another thing here is that, like I said in the talk, entities is an implementation of the actor model, and if you work with other actor actor frameworks, then everything becomes an actor, and then it's more likely to implement also that kind of logic within your actor. However, with entities, you are part of the Azure Durable Functions framework, which is a family of features where entities is only one of them, and orchestrators have a better place to capture your workflow and to and then from the workflow from the orchestrator interact with the entity. So it's kind of you have to think about how they can work together. But doing a lot of I/O and going outside to external services and I don't know business logic in an entity, I'm not sure if it's very scalable. So yeah, it's a complicated question, but maybe a little bit longer answer there. And I would love to continue the discussion on Discord. But yeah, great question.
Yeah, for sure. Yeah, thanks for the answer. Also, I feel like this is warrants a longer discussion maybe. So yeah, definitely join our Discord if you want to get more into this, because I think that's there's a lot to unpack here. And hey, so I think we're already at the point when we said that we're gonna be done. So unless you have, so I see someone's typing, so I'm gonna stretch this out until they're done typing. Oh, they stopped now.
So some time now. Maybe even a longer answer than mine.
Oh, it was mainly thanks for the talk. Yeah, people were very excited about your talk and also about the VS Code love that we are all showing. And yes, of course, VS Code, the best. Anyway, so I would just like to also again remind you to go to serverlessdays.nl to sign up for the conference, which is free. And we are going to announce more speakers. We have announced 2 amazing speakers, Anne Stanley and Simona Kotin, who will be giving the keynotes. So already, like, there's no reason for you not to come. But also, if you just want to engage with us in some other way, you want to be a speaker, for example, or you want to help us organize the conference or the meetup events, or you have any other ideas how we could improve on all this, then please get in touch with us. You can email us on amsterdam@serverlessdays.io. You can find us on Twitter under ServerlessDAMS, or you can join our Discord. And thank you so much for joining. And please come to the Discord. We're going to have a couple more drinks and chats and the good, community stuff that we're all here for. And hope to see you again very soon. Thank you. Bye-bye.